let's see, I guess it was Tuesday, we worked with writing things in a plus bi form and converting it to our cis theta form. Remember, cis stands for the expanded form of cosine theta plus I sine of theta. And I just abbreviated cis because it makes it less writing time. Okay, on problems, you're going to be rounded to the nearest hundreds. Use exact values when you can. So if you got a 30, a 45, a common angle, you can use your exact answers. The other thing is you got to be careful. If you're in degrees, make sure your calculator's in degrees. If it's in rads, make sure your calculator's in rads. Okay, so the first formula is called the product, and these are all mixed up in this assignment 10 through 21. They don't do all the product first and then all the quotient. You got to pay attention. Product means multiply and quotient means divide, so they're all mixed in. When you do product rule, you multiply the r's, but you add the angles. When you do quotient rule, you divide the r's, so that just put it over each other, so that means to divide, and then you subtract your angles. So those are two formulas you're going to be using. When you multiply the r's, but you add the angles. When you divide the r's, but you subtract the angles. Now, example, and you're going to write your answer in both r cis theta and a plus bi form. So you're going to get two answers per problem. Two answers per problem. And I'm going to do one. Is it okay if I write cis? Does everybody understand the cis?
Yeah.
Yes. It'll be like that on the test too.
I'll probably write it both. So this is a product, right? Because it's a multiplication. So in a product, you multiply the r's, so 2 times 3 is 6, and you add the angle. So 30 plus 40 is 70. There's your first answer. Now, how did we change r cis theta to a plus bi Tuesday? How did we change it to this form, a plus bi? Distributive properties, all you got to have. That's why we got to have our calculator. So what's 6 times the cosine is 70? We're rounding to the nearest hundreds.
2.05.
And everybody double check it. Let me know if it's different. Okay, 6 times the sine is 70.
We add those, right?
You're going to say plus or minus in between, depending on what it ends up being. This will be plus. 5.64, and this is the I. Remember, the sign always goes with the I. You can't add these together because this has the I and this one doesn't.
I had 4.64.
4.64? Somebody else check it.
I got 5.64.
Okay, 6 times sine is 70.
Is it second sign or
Just sine.
Okay.
Now, if it's in simple degrees, that's as easy as it gets. Okay? Now, what if I have square root of 3 cis 5 pi over 4, and I want to divide it by 3 cis pi over 2. Now, what is this?
It's in the
Now, it's in radians, but I wouldn't change my calculator radians because it's going to take you longer to go 5 times pi divided by 4 than it would for you to just change it to degrees by multiplying by 180 over pi. So I would do that step first. So it would be 225. And that one would be 90, right? Is everybody agreeable there? So if it has it using the pi in the problem, I would still keep my calculator in degrees and I would change it to degrees. Now, what are we supposed to do when we have a quotient?
Put the r's over each other and then subtract the angles.
So radical 3 over 3, subtract the angles. So what's 225 subtract 90?
135.
Okay, so there's one answer right there. Now to get the second answer, you can use your calculator and distribute it. So you want to take the square root of 3 divided by 3. And if you have a calculator that opens parentheses, make sure you close them. Multiply it times the cosine of 135.
Negative 0.41.
0.41.
Yeah, that's what I got.
Okay, we got two people. Got another?
That's what I
Mm-hmm.
Okay, next one. Square root of 3 divided by 3 times the sine of 135.
got. 0.41.
Should be the same. Why?
Because it had 45.
That's 45, good. And a 45, don't I know that's the square root of 2 over 2 for sine and cosine?
Mm-hmm.
So I could have done it exact, which I would have got square root of 6 over 6,
Was 45?
135, because it goes in the second quadrant. And then it would be plus square root of 6 over 6. Somebody check. Is the square root of 6 divided by 6, is it the same as 0.41?
Yeah.
So see, you gotta double check if you use your exact as well. You guys got this, right? Okay, so I did one that was in totally degrees, total degrees. I did one that was, it was rads, but it was one that you could convert easily, right?
Uh-huh.
Now, let's look at this one. What you notice? You're in radians. Now is when I would change my calculator to rads. Because this one, if you take it times 180 divided by pi, you're going to have a decimal that you'd have to keep and work with. So it'd be easier to change the calculator into radians. So that DRG key. Remember where to get your DRG or the mode to change. So now, this is a product. So in a product, what do we do with our R's? So we're going to get what? 3 square roots of 6? Because when you multiply radicals, it's outside times outside and inside times inside. Adding the angle, so this is easy to add. 5 plus 2 is 7. So there's the first answer written in cis form, R-cis form. Now you need your calculator in rads in order to convert it to the A plus BI form. Now Becca, do you know where your rad conversion is? It says DRG. Yeah. And, well, no, hit it, and then move it over, and then hit enter. Yeah, there you go. That was probably a mode. Yeah. There it is. We want to, so we should say, yeah, okay. The only problem when you convert your calculator to rads, you gotta remember to go back to degrees when you need to, because they're gonna be back and forth on this whole assignment. Okay, so somebody tell me what the first one is. What's 3 times the square root of 6
5.5.
times the cosine of 7? 5.54? 5.54.
And then 4.83. Or 83.
4.8.
4.83.
Anybody else? We agree on those values.
Did you come second?
This is 3 square roots of 6 times cosine of 7. The second one is 3 square roots of 6 times the sine of 7.
Times 3.
You're going to go 7 cosine times the square root of 6 times 3. Oh, we agree? Okay, let's do another one. This time let's go with 12 cis of 2.1 divided by 2 cis of 3.5. Again, what are we in?
Math.
Rads. So we divide, we're in division, it's a quotient, so what do we do with our R's?
Is that 2.1?
Yes. So 12 divided by 2 is going to end up being 6. Cis of, what do we do with our angles? Subtract them. So what's 2.1 minus 3.5?
Negative 1.4.
And you will have negatives occasionally. So there's the first answer. That's an RSIS form. Okay, now, to get the second answer, the answer that changes it to A plus BI form, you use distributive property. So what's 6 times the cosine of negative 1.4?
1.02.
1.02. Okay, 6 times the sine of a negative 1.4.
Negative 5.91.
Negative 9 point.
5.911.
5.91.
Yes.
Negative?
Yes.
Yes.
Okay, are we all agreeing on our values? Okay, still another one. I just want to do, we've done 2 with just totally rads, right?
Yeah.
Okay, now, what will I do on this one? That was quotient, wasn't it? So now I'm going to do multiplication.
Is that 7 times? Yes.
What would I do on this example? Convert it to degrees, which when you're doing that converting, what do you know you got to do to your calculator? Change it to degrees. So if I take this times 180 over pi, pi's cancel, 3 goes in 180, 60, so 60 times 7 is 420. And that one's 45, right?
Yes.
Does everybody remember that one? Now we're ready to get our first answer, the r cis theta. So we're multiplying, so what do we do to the r's?
Multiply them.
So 8 times 2 is,
16.
what do we do with our angles?
Add
So 420 plus 45 is,
45.
You have to subtract that?
no, when it's quotient, you subtract them.
Okay.
There's the first answer. It's in r cis theta form. Now to get the second answer, you need to go to your calculator, make sure it's in degrees. 16 times the cosine of 465,
Negative 4.14.
negative 4.14. And the next one,
15.45.
positive.
Yes.
Does everybody concur on those values?
Yep.
Yeah.
Okay, now we'll go to so what form is this in?
Degrees.
It's in degrees, so all you gotta do is do the problem, right? So you, quotient means you divide the r's, so that one you'd have to rationalize, right, to get rid of the radical in the denominator. You get a radical 6 over 3,
Yes.
and what do you do with your angles?
Subtract them.
So 80 take away 20,
16.
60.
Yes.
So there's the first answer. Now what do we do to convert it?
.41. 0.71.
Yeah, this one is one we should have known, right? 60
Yeah.
degrees? What's the cosine of 60 degrees? So square root of 3, or square root of 6 over 3 times 1/2 would be the square root of 6 over 6. And we did that one a while ago. We know that's 0.41. Now what's the sine of 60? Square root of 3 over 2. So we get square root of 18 over 6. And 18 can simplify to 9 times 2, which is 3 square roots of 2. So I end up with square root of 2 over 2. And that would be the one I would check. What's the square root of 2 divided by 2? 0.71.
Yep.
Okay, now, do you guys need me to do more examples?
No.
Okay.
I've done 2 of each type you can see. Yes, ma'am.
Will there be any where it's like square root of 2 CIS 80 degrees divided by 3 square root of 2 CIS 2? And like one's in degrees and one's in rads? Or will
No,
it
no.
not be like that?
they'll either have them both in degrees, both with the pi involved, or whole numbers with reds.
Would you just change one of them?
Yes, Yeah.
What do you know if we can do the rest of one?
that doesn't have a degree symbol.
Oh, okay.
Remember to watch for your degree symbol.
Okay.
Okay, I'd like to see everybody's first three. And then, let's see, who has gone on Tuesday? Okay, you two. Then, what we did on Tuesday was the R-sis theta.